Hey there, welcome on my channel. If you're watching this video, you're probably thinking something like this. Then you started watching videos or reading forums, and you found words like these ones. They can surely be a lot to take in if you don't know what they're about, and most of the times everything you need to know about is scattered among a lot of different resources, making it harder to make a full picture of what you need for your game. With this video, I would like to show you the meaning behind all of these terms, helping you on making the right decisions developing your ideas. While the focus of the video are resources built around Unity, the concepts behind them can be used on every engine, you'll just need to translate them. So, without further ado, let's get started. Network topology defines the way a network is arranged, including how links and nodes relate to each other, clients and hosts, physical machines and virtual. The first topology we will see is the peer-to-peer. This topology distributes the communication and processing responsibilities among all connected devices, known as peers. Each device acts both as a client and a server, allowing direct communication and data sharing between peers. They can exchange game-related information, such as player positions, events, and other data, without relying on a central authority. One of the advantages is its potential for scalability, particularly useful for games with large-scale multiplayer experiences. However, it also presents some challenges, such as fairness, cheating prevention, or latency issues. The next topology we'll see is the client-server. This topology is one of the most common architectures used in video game development. The clients are responsible for direct interaction with the end users, and can perform functions such as graphics rendering and commands input. On the other hand, the server is considered the central point of control and management. It can validate the actions taken by the clients and handles the synchronization of game state among all participants, running a local simulation of the game world. Clients will then receive updates of the server simulation, showing them to the players. This approach helps maintain a consistent game environment and reduces the risks of fraud or manipulation by clients. To implement a client-server architecture, you can choose between these two different options: listen server or dedicated server. In the first case, one of the clients will also serve as the server, while in the second case, it will be dedicated and its sole purpose will be to process and send data back to the clients. Below is a list of the major pros and cons of both solutions so that you can compare them. If you're wondering which one is better for you, the answer, as usual, is it depends. In general, we can say that the listen server solution is more suitable for social or cooperative games, while the dedicated server solution is more suitable for fast-paced or competitive games, where lag and cheating have a much greater impact. I'm sure dedicated servers caught your attention, and you want to know more about it. Let me introduce them to you. As we said earlier, a dedicated server is a powerful computer or a network of computers solely devoted to hosting and managing the game. Unlike shared hosting or peer-to-peer networks, dedicated servers provide a centralized infrastructure that ensures optimal performance, scalability, and control. They have the processing power and resources to handle a large number of simultaneous players, ensuring a seamless and lag-free gaming experience. Moreover, dedicated servers offer enhanced security and fairness. By centralizing game operations, they can enforce rules, prevent cheating, and protect sensitive player data, providing a controlled environment where players can compete or cooperate, knowing that everyone is playing on an equal footing. Alright, before we proceed, we need to make a note. Everything you'll see from now on will be focused on game servers created using Unity, but you should know that it is possible to create dedicated servers without it. In fact, we can create game servers using only programming languages such as Node.js, Python, Golang, Rust, or much more. This way, it is possible to write performant code, having maximum control over all the data that is passed between the server and the clients, and on the way it is processed. However, as effective as this technique may be, it is certainly more resource intensive. So we won't discuss this type of server in detail, but if you are interested, please let me know in the comments. Now, I think you're probably asking yourself, so I just create one single game server for all of my players? Well, let me explain further. If, for example, we create a game for a competitive 2 versus 2 match, and later 8 players press the play button to let them play, we will need 2 different servers. 4 players per server. So, we need to allocate servers based on players' requests. How do we do this? Let me say that different technologies work on different ways, but we can generalize the process as it follows. The first thing you need to know is who will host your servers. You can build your own infrastructure, or use a service that just do it for you. Regardless of what you choose, this service will surely provide you a way, SDK or API, to interact with it. With interact, I mean, for example, a way to create a server, to close one, to provide server statistics, or some other utilities. You implement this methods on your game and build it. Before uploading your game, you can take an optional step. You can put your build on a container. We won't cover what containers are, but if you don't already know, they bundle your game with all of its dependencies together, or in a container. In this way, you can always be sure that your game will behave almost everywhere on the same way. Most of the dedicated server services will let you upload a Docker image. First part completed, you later deploy your game to the stores, and players start to play. When the matchmaking system put users together, it requests a new server from the cloud service. The cloud service will work on it, and deploy a new server for the players that requested it. Finally, it passed the new server address and port to the players that will connect to it. Now, let's focus on the services I mentioned earlier. The first type we will cover are the ones that already offer you a built infrastructure. Or translated, the easier way. Let's call them orchestrated services. The most greater advantage of these services is the ease of use, compared to the manually built ones. Just to say, you could have an online server set up in less than 10 minutes. They also offer security features, technical support, and a lot more. The most of them also provide you with different data centers, letting your players connect to the closer, improving latency issues. But as always, nothing is free. This features comes with a price that is not affordable by everyone, and especially by solo developers starting for hobby. The main services that I found myself are these. But I'm sure there are a lot more of them out there, like EdgeGap. One last word, you can test most of them for free. Have a look on the official pages, but be sure to carefully read the terms. Lastly, let's see how you can build your own infrastructure. The main solution that I can advise you is Agance, a free and open source platform for deploying, hosting, scaling, and orchestrating dedicated game servers. It is built on top of Kubernetes, probably the world leader on containers orchestration. Using Agance, you can have more granular control over the behavior of your infrastructure, modeling it around your server needs. Basically, it handles the setup of game servers, providing an SDK that you can include in your game to update server status. It works similarly to orchestrated service, but here you have to manually set the specs. Built on top of Kubernetes means that you can host it everywhere Kubernetes runs. You can host it on your machines using Minikube, a local version of Kubernetes. Install it on your local PCs or on VPS and bare metal machines paid online. Or as alternative, you can use a Kubernetes providers, like the most famous from Google, Amazon, or Azure, or every other host. But do note that orchestrating your services requires a lot more of technical knowledge about containers and orchestration services. And at the end of the day, paying for Kubernetes hosts may not be cheaper than orchestrated services. By the way, check the link on overlay to fully understand the pros and cons. So we've seen how to make dedicated servers, but let's suppose you don't want one, and you choose to let your players host their games. Let's see how you can do this. First of all, if your players will host the games, you won't need server build nor server hosting. This surely is good on terms of costs, but you will have to face some other problems. To better explain this, let's first see how Listen Servers works. To put it simply, when two players play your game, and via the matchmaking system they are paired, one of them need to also start a server on his device, so that the other can connect. To decide the client that will also behave as host, you can consider to run a query, for example on the performance of the device, or your own criteria, or again, you can simply choose randomly. So one of them started the server, and the other will have to connect. You can think it's done, but it's not. We should consider how can device connects together, and it's not as simple as you may think. The most simple configuration is the one where the clients are under the same network. They'll just share their IP addresses, and done. But honestly talking, if you're here, you're probably imagining a bigger picture, not just constrained on LAN parties. If we try the same connection with addresses over internet, it will simply fail. This happens because your home networks translate your device IP. We won't cover the reason of it, but know that this can't be changed. So, just find workarounds. Solution number 1. Port forwarding. With this method, you have to instruct your modem, telling him that requests on a specified port are to be routed to your device. Honestly, for a game it's unproposable. Do you imagine yourself port forwarding every game you install? I don't think. And above it, settings on modem are not easy for everyone, and users won't always have the access. Solution number 2. Relay servers. Relay servers are a particular type of servers that work as a middleman, establishing connection with each player, so clients don't have to. Relay purpose is to let messages from a client be relayed to the others. Don't confuse them as game servers. Always remember that the game server is one of the clients. You can host your own relay or you can use a service that do it for you, but consider that you have to pay to have them up and running. One more thing, working separately from clients, relays can detect their disconnection, potentially running a host migration. Solution number 3. NAT punch through. This solution implements advanced techniques to literally punch the NAT services, obtaining the address of the client behind them. This solution does bring some security concerns compared to relay servers, because having the address of the other client can potentially be tempting for malicious users. Furthermore, this solution is not reliable, it can often fail to execute. But surely, it's the suitable one if you don't want to pay anything. Solution 3+1. Both. You can consider to first run a NAT punch through and, if it fails, use a relay server. Netcodes, or frameworks, are tools that facilitate the development of online multiplayer games, allowing you to manage the communication between players, the synchronization of objects, the game logic, and other features. The netcodes are built on top of the Unity engine, but also expanding on functionalities offered by network libraries. Netcode add high-level features, but they need solid foundations that think instead of the real exchange of data between different clients. This is where network libraries come into play, which are also called transports. Transports offer low-level functionalities that allow developers to manage a base connection between clients and to share data among them. Different transports offer different functionalities, targeting some aspects or some others. Netcodes usually allow users to change the transports, so you should consider to at least watch the differences among them. Users might also think of creating their own multiplayer features by building only with transports. This would allow complete control over the data transferred and received, allowing significant optimizations, but the complexity of development would increase dramatically. We will now see together the main netcodes to build your games. Netcode for game objects. previously known as Moppy. It's the new official solution offered by Unity. Officially launched on mid-2022, it offers many useful functionalities, but some are still in development, and checking the roadmap you can see the next steps. The code is open source, and welcomes contributes from the community, and this is great. And talking about community, it surely is large. You can get started with a lot of resources, from videos to articles, covering your doubts. By default, netcode for game objects uses the Unity Transport package as low-level transport, the official transport from Unity, but you can change it with many more, also built from the community. You can potentially build any type of game with this, but Unity now offers you a different alternative when you want competitive games that require performance servers and higher performance. We'll see it later. One last thing. Netcode for game objects integrates the Unity gaming services to the fullest. Relay server, lobby, multiplay or matchmaking, and all the other services from Unity are fully compatible with it, allowing you to build a complete infrastructure around your game. Netcode for entities. Let's talk about the new solution offered by Unity. It's part of DOT's data-oriented technology stack and uses Unity's Entity Component System, or ECS, as foundation. It provides a server authoritative framework with prediction, interpolation, and lag compensation, suitable for competitive action or fast-paced games. It exited the test phase while I was still writing this video, on June 2023. Up to now, there are few resources online, and forums are in large part outdated. The official documentation, too, is a bit fragmented, but everything will surely improve with the time. An important factor to consider is that data-driven programming is quite different from Unity's mono behavior. You'll have to learn it well if you want to proceed. Mirror. Probably the framework that has been here the longest. Born on top of the old official solutions from Unity, Unnet and Hoppy. From the community, they initially fixed bugs and improved performance. Later they started on building new features to it, reaching the actual state. It focuses on ease of use and scalability, proving to be a solid choice for games with many concurrent users. The project has a great documentation, covering technical examples, theoric topics and extras that will surely help you. Community contribute is also high, letting you getting started in a short time. Photon Fusion. The new flagship from Photon, built on the experience maturated with the now legacy Pun and Bolt, both widely used with Unity. It expands the old technologies, bringing in features such as client-side prediction, lag compensation, area of interest, and a lot more. As you can see on screen, benchmarks versus other solutions prove this netcode to be a solid choice. Photon Cloud is the backbone of the framework, bringing global connectivity and to allow low-latency gaming, but it isn't free. Up to now, the free plan allows 20 concurrent users. With Photon Cloud, you'll have a lighter development of the game, helping you connecting players even in the case of listened servers, saving you the hassle from relays or NAT punch-throughs. But you still use the cloud even with dedicated servers, so you'll pay for both hosting and Photon Cloud together. Consider this. Photon Quantum. Quantum is a deterministic ECS framework. It is based on the predict rollback approach, which is ideal for latency-sensitive online games such as action RPGs, sports games, fighting games, FPS, and more. The idea behind deterministic engines is that if we provide same inputs to different devices, and everyone produce the same simulation, then there is no need to sync things such as positions, movements, physics, and so on. Just share the input of the players, and everyone will have the same game. There are an infinite number of pros on doing it, from latency to performance to security. Surely a valid option to be considered, but with all of this comes a higher price too. You can get started with 20 concurrent users for free, but then the fee rise a lot, compared to Fusion 2. Fishnet. Fishnet is another network solution I stumbled upon looking for answers on Unity forums. It's built from the ground up with design on server authoritative, but also support listen servers. The developer claims to have reached a high level of performance, also including a lot of features, with a few hidden with a pro plan. On the official pages, we can find a benchmark comparison with Mirror, and it surely is interesting. You should consider it too. Okay, I think I covered almost all the main netcodes for your games. Surely this list is not complete. There are a lot of others, like Heroic Nakama or Dark Rift 2. I won't cover them, but let the others know in the comments if you have more on it. You're probably asking yourself which one is better for you, and guess what? It depends. It depends on a lot of factors. How much performance does your game need? How many concurrent users a single match has to handle? How much money can you spend on it? And a lot more. I'll tell you what choices I would make, but just consider them as personal opinions, that's all. For co-op or turn-based games, I would probably go with netcode for game objects. I think the netcode integrates easily with Unity, and I find it easy to work with. Also, with a listen server architecture, I would keep the costs low or null. Considering to spending a little more money, I'll probably move to Photon Fusion. The benchmarks say a lot of it, and I think it would boost my game performance. As last choice, I'll think to Fishnet. I've seen little of it, but based on what the documentation says, I'll probably give it a go. For competitive games, like FPS, MOBA, or racing with a moderate number of concurrent users, I would probably think to netcode for entities. I think the learning curve is steep, but I would really like to master it, because it offers a lot of features that if used correctly would surely make a great game, and the price, it's basically free. Here I would consider a dedicated server rather than a listen server, but I would have to think more on the costs. With more money to use on my project, I think I would rather move to Photon Quantum. It's the same idea behind netcode for entities, but with more resources to getting started and a more stable engine. As a middle way, I would surely consider Fusion. Another type of games that we can talk about is MMORPGs. Here the stable and proved choice would be Mirror, but if you want to level up the performance of the servers, netcode for entities or Fishnet would likely be the other options. Talking about MMORPGs, I would like to say one more thing. We briefly discussed it on the dedicated server section, but Unity is not a great choice for game servers if you care about robustness, stability, and scale. If you want to reach these specs, you'll probably have to write your own server with languages like Node.js, Golang, Rust, or something similar. Writing your own server will prevent you from sharing logic and assets on the same code base that is Unity, so you'll likely have to rewrite everything from the ground up. This will take a lot of time and effort, but the results will be a greatly improved server performance, allowing for a lot more connections and reduced computing costs. Okay, I think we covered all the main topics you have to know before considering how to build your games. One more topic I think could be useful for you is the security. Cheating on a single-player game is bad, but cheating on multiplayer games is the worst. I give you on overlay 2 more links to resources that helped me a lot. And with this, we are done. I hope this video helped you clear things up to better understand the big world behind multiplayer games. We just scratched the surface, talking only of the theory, but I hope to dive deeper on the code on future videos. Always remember that technologies evolve during time. Since I started thinking on this video, a lot of things changed, new technologies born, and some others died. So if you watch this video later, always have a look on the internet before going all in. And this is really everything from me. Leave a like, subscribe if you want to keep me company on this journey, and leave a comment if you have something to add or to correct. I'm not the best, but I want to be. I hope to reach you soon with more. Till then, have many productive days. Bye.